Today we're going to take a look at section 2.1, which is reasoning and logic. Okay, so this particular section might feel to you like it's not math. That's okay. It is. It's logic, and logic is mathematics. But there's not going to be like number crunching, and you're not going to need you might want to use a calculator just to do some simple arithmetic kind of things, but you don't really need it. It would just be more for convenience, okay? So we're going to get started with this one. And to start with, we're going to have a little bit of vocabulary, okay? So the first vocab word is the word statement. A statement is a sentence that is either true or false. For example, I ate eggs for breakfast. Okay, if I say that, it's either true or it's false. There's no sort of like, well, I sort of kind of ate eggs for breakfast. No, I either did or I didn't. Okay, that's a statement. This would be a non-example. What did I eat for breakfast? Why is this not a statement? It's a question, right? The answer cannot be true or false to this. That doesn't make sense. Right? I can't ask my son, what did you eat for breakfast, and him say true. He might try that, actually. That's the kind of kid I've got. But, it doesn't make any sense. That's not a statement. It is a question. Another type of sentence that doesn't fit this description very well is a command. If I say, eat your breakfast, even without the tone, right? Eat your breakfast. It's not a statement. It's neither true nor false. It's a command, okay? A negation is the logical opposite of a statement. And if a statement is written as P, then the negation is written as tilde P. So tilde means opposite of. Looks a little bit like a negative sign when we do, algebra. So for the example that I gave, it works pretty well, right? If I use the example from above, that's I ate eggs for breakfast. What would be the logical opposite, i.e. the negation of I ate eggs for breakfast? Yeah, don't overthink this, right? Yeah, I did not. Now, that sounds pretty straightforward. And for simple statements like the one I gave you, it is very straightforward. But it can be more complicated with what we're about to see next. What we're about to see next is something called quantifiers. There are two types of quantifiers. There are universal quantifiers, refer to each and every element in a set. So they look something like all boys have stinky feet. Okay, that's got a universal quantifier in it, the word all at the beginning. All dogs go to heaven. No cats are nice. I have a daughter who believes that. All no. These are the ones that get you in trouble when you say them to your parents, right? You always, whatever, or you never, whatever. And you're usually lying when you say it, right? Usually. Always and nevers. Okay, so what's the opposite of that? Not the opposite, but the other type. The other type is called an existential quantifier. An existential quantifier refers to a portion of something happening. So some, at least one, or there exists are sort of keywords that go with existential quantifiers. For example, some people like the rain. Now, I don't mind the rain necessarily, but not super fond of walking outside in it today. Now notice this doesn't say that some people don't. We sort of feel like it's probably leaving that possibility in it, right? That some people might not. It's certainly not making the claim that everyone does or that no one does. It's just saying some people do. These quantifiers, all, none, some, there exist, make quantifying or make negating things more difficult. So that is the disclaimer right here. Note, creating negations when quantifiers are present takes more care than when they're not present. When they're not present, we just put the word not in there, right? I did not do that. Easy. But when you put the words all or some or no inside of there, it gets more difficult to make the negations. So let's think about the statements that have a word all in them. All dogs go to heaven. All boys have stinky feet. All. This is like you telling your mom, you always get mad at me when I do whatever. Always. All. What is the least amount of something that could make that statement false? Here's what, we'll use the one on my screen. All dogs go to heaven. What is the least amount that could make that statement false? What's that?
0 or none.
0 or none what? Doing what? Going to heaven, right? So the least amount that could change and make the statement false is 1, actually. 1 dog that doesn't go to heaven. Are you guys with me? If I say all dogs go to heaven and you're like, no, you never met Butch. Butch is definitely not there, right? That's all it would take. 1 dog and this statement would be false. All it takes is that one time your mom did not get mad at you when you're saying she always did to make your statement false, right? That's all it takes. So that's what a negation is. The negation is the least amount that you can change something and make it false. So all dogs go to heaven. The least amount that we could change it is to say, there exists a dog. I called him Butch, right? We won't put Butch's name in there. But yes, there exists a dog that does not go. It sounds a little weird because we say it kind of past tensey, but does not go to heaven. Now, in the place of there exists, you could have used the word some as well. Some dogs, I know I got to get my subject-verb agreement, but some dogs don't go to heaven. Okay? So that'll be all right as well. All it takes is a very bare minimum of 1. If I say some, it actually has the possibility of just being 1. That would be actually okay. How about this one? There's a couple of ways to negate this. This one says, some of my classes this semester are hard. Very good. Okay, say that a little bit louder so everybody can hear you.
None of my classes this semester are hard.
None of my classes. this semester are hard. Okay, I'm going to give you one other way you could do the negation for this, and then we'll talk about some things that you might try to do that wouldn't work, okay? Notice what changed. This is an existential quantifier, right? Some. And it changed to a universal quantifier, none. This is a universal quantifier, all. And it changed to an existential quantifier, there exists, or some. Okay? That always, see I used the existential one, it always works like that. When you do a negation, you're trading one type of quantifier for the other one. So if you haven't traded that, you've made a mistake. For example, actually, let me give you the other one that actually works here, and then I'll show you an example of one that doesn't. What's another universal quantifier besides none? All. Let's try to do this with the word all. The one Alicia gave is the most natural description. So hers is the better answer sort of grammatically. But we could do it with all and it would work. If some of my classes this semester are hard, what would I have to say about all of my classes in order to make the statement false? Close. So we could say that is they're what? They're not hard. That's better. Yes. So all of my classes this semester are not hard. Okay, it's correct. It sounds a little funny. We don't talk like that, right? It's just not the normal syntax that we would use, but it is technically correct, and it would be okay. So Alicia made a guess when she changed the words not hard that I wanted her to say to easy. Any idea why I was like, be careful about that? Any idea why that's not a good idea? Yeah. How many of you have had a class where you're like, it's not really hard, it's not really easy? Have you had classes like that? I know I did. I remember having classes where I'm like, it is a ton of work, but it's not really hard work. There's just a lot of it. That's how I described those particular classes in my world. So we want to be really careful that we don't change the meaning accidentally, because just because something's not hard doesn't necessarily mean it's easy. Are you with me on that? Okay. Let me also tell you another common mistake when people change the words some. Sometimes I will have students who start with this one that says, some of my classes this semester are hard, and they want to negate it and say, some of my classes this semester are not hard. Why is that not a negation? I didn't trade it for the universal quantifier. That's sort of me telling you how it works. But why conceptually does that not work? Could be, at least, right? Could you have those two statements true at the same time? Some of my classes are hard. Some of my classes are not hard. Can those both be true at the same time? Yeah. That's not what negations are. Negations have to be one of them's true and one of them's false. Go back to my dogs going to heaven one. It cannot be both true that all dogs go to heaven and that Butch doesn't if Butch is a dog. We can't have that happening, right? It's got to be one or the other. But if I say some of my classes this semester are hard, some of my classes this semester are not hard, you're like, okay, both of those statements can be equally true, right? They certainly could. In fact, they probably are for most people, most of the time. Okay, so you want to be careful, and you're going right back to what you had said. Where's my thing? What Savannah said. Samantha said when she said, you got to make sure you're changing it, right? It's got to change from universal to existential or existential to universal. All right. We're going to take a look at an organized way of looking at truth values. These are called truth tables. Truth tables are used to show all possible true-false patterns for statements. So So hold off on writing the compound statement stuff down. Just write down to the negations in a truth table, okay? So just write down to here. All right, so what we're going to do is we're going to call one column header P. P is our statement. It's the all dogs go to heaven, or it's the some of my classes are hard. It represents some statement. And my second column is going to represent the negation of P. Tilde P. Now what I said just a moment ago is that if the statement, all dogs go to heaven, is true, then its negation, Butch didn't go to heaven, is false. They cannot both be true at the same time. And likewise, if my statement, all dogs go to heaven, is false, then that must mean that there does indeed exist a dog that did not go to heaven, and that statement would be true. Are you with me? Okay, we're going to get more complicated, but this is our first one, negations. Now, some statements are called compound statements. Compound statements are two statements joined with a connective, such as and, or if then. There's another connective that sometimes shows up. It's the word but. But means the same thing as and. I got up this morning, but I didn't eat breakfast. Well, that really means I got up this morning and I didn't eat breakfast, right? It's the same thing. So if you see the word but, it's interchangeable with the word and. All right. We're going to do the and one first. Two statements joined with the word and. Sorry, I know you guys have to write more today. I apologize. Am I good to switch slides? Yeah? Okay. An and statement. Okay, having two pieces, two statements joined with the word and is called a conjunction. A conjunction is the equivalent of an and statement. It's true if both statements are true. And if the statements are P and Q, then the and statement is written as an upside down arrow or an upside down V. Kind of looks like 2/3 of the capital letter N. A little bit. Okay, we're going to look at a truth table representing this situation. So this one's a bit longer and a bit wider. On this, you'll need 3 columns. It doesn't need to be a lot longer, I guess. But you'll need 3 columns. One column is statement P, one column is statement Q, and one column is the compound statement P and Q. And we're going to talk about this conceptually using a particular P and Q. I'm going to let our statement P be I am a mom, and statement Q be I teach math. and we're going to think about what happens. Now, going back to our statements, these are two separate statements, right? One thing does not mean the other thing has to be true. Agreed? I could be both of these things. I could be neither of these things. I could be one of them and not the other one. All those things are possible. So it is possible with any two statements to have four things happen. It could be that both statements are true individually. It could be that the first statement's true and the second statement's false. It could be that the first statement's false and the second statement's true. Or it could be that both statements are false. Everybody good so far? Okay, so these are my four possibilities, and they always look like this. If you're in the habit of doing so, it's actually kind of nice to think about it this way. This one always goes TTFF, and this one always goes TFTF. So no matter what the rest of our table looks like, those two columns always look like that. Okay? Always. So what happens next? Well, I want to give you some examples. So let's say I walk in. You guys know a little bit about me because I'm a teacher, and I've talked to you a little bit about my family. And I walk in and I say, I teach math, and I'm a mom. And you would say, yes, that's true, right? Both of those statements individually are true. So putting an and between them is also true. Agreed? Okay. Which one did I use? Okay. So let's say then that Miss Justice. Do you guys know Miss Justice? Okay, Miss Justice. Okay. So let's say Miss Justice walks in here and she says, I'm a mom and I teach math. What do you guys know about Miss Justice? Is she a mom? Yes. Does she teach math? No. What does she teach? Special ed. So you might sort of fuzzy kind of like she does teach math within the special ed context, but special ed is her specialty, right? Yeah. So if she walks in and she says, I teach math and I'm a mom, and you're going to be like, no, correct? Because both of those statements are not true. Just one of them is. So you would say, no, that's a false statement. All right, do you guys know Dr. Tucker? Does anybody know Dr. Tucker? Got some nods. Okay, so what's that? She's the best. I'm going to tell her you said that. She would love to hear that. Dr. Tucker is the chair of our math department. She's my colleague over there. Just so that you know, Dr. Tucker is not married and she has no children. Otherwise, this isn't going to work. Okay, I got to pick up people that work with my situation. So Dr. Tucker walks in and she says, I'm a mom and I teach math. And you say, no, she does teach math. That part's true, but she's not a mom. So that would be a false statement if she were to come in and she were to say that. You all know the last one I'm going to do. You ready? Dr. Whitlock. Dr. Whitlock comes into our classroom and he says, I'm a mom and I teach math, and you all probably laugh. Actually, is what you really do. But you're all like, no, right? It doesn't work. That's a false statement. So take a look back up here what this said. It says a conjunction is true if both statements are true, and notice that is the only true value in my conjunctive column. So only place that it happens is if both of the pieces are true. All right, conjunctions. Disjunctions are my next one. Disjunctions are an equivalent of an or statement. And they're true if either statement is or both statements are true. And it is written P or Q. So the or part actually looks like a V. It's flipped upside down from my and symbol. Okay, so based on what I did on the last example, you should be able to fill in the P column and the Q column. What is going to go from top to bottom underneath P? T, T, F, F. Very good. And what is going to go top to bottom underneath Q? Right. T, F, T, F. We're going to use our same 4 people. Almost said 5. I didn't have 5. I had 4. 4 people, and they're going to come in and talk to you. The first one is me, and I'm going to come in and say, I'm a mom or I teach math. And you would say, well, it's really weird that she said or between those, but that still's true, right? It is. Sounds a little funny, but it's true. She is a mom or she teaches math. Actually, both. Then Miss Justice comes in and she says, I'm a mom or I teach math. And you say, that's true. That's a true statement. She is a mom, just in case I didn't clarify that before. You guys probably know one of her daughters. She's here at school. Third one was Dr. Tucker. Dr. Tucker comes in and says, I'm a mom or I teach math. And based on what I've told you, you would know that that also is true because she's a math professor. She's actually next door right now, in the next room over. The last one is Dr. Whitlock comes in and he says, I'm a mom or I teach math. And you say, no, that still doesn't work, right? Still false. So again, notice how it describes it. It says it will be true if either statement is or both statements are true. And sure enough, I have 3 rows that all ended in T truth values. Either individual statement is true or both of them are. All right, so what we're going to do next is we're going to create a truth table for a random combination of things. The truth table we're going to do is for P and tilde Q. So anytime you're asked to create a truth table, you're always going to create the columns P and Q first, and they're always going to have the same T's and F's that we've already done. So none of that changes. All that's the same. The next thing you do is you look at the statement you're trying to make a claim about and notice if there's any other piece of it before you just throw it all together that needs to be present. There actually is in ours. We have tilde Q right here. Do you guys see that? I already have a Q column, but I don't have a tilde Q column, so now I need one, tilde Q. Now I have each of the individual pieces before I compound them together. I have P, I have tilde Q, so now I can do a column for the combination of P and tilde Q. So, tilde Q column. What will it look like top to bottom? Yeah, the opposite of Q, which would be false, true, false, true. Is everyone good with that? Excellent. So the next column needs to compare. It needs to compare the P column with the tilde Q column. You can ignore the Q column, right? That's not really part of it. That's how we figured out tilde Q anyway, but it's not part of the final result. Now, when is an AND statement true? If both statements are true, right? So on the first row, I have, right here, true in the first column, and I have false in the second blue column. So when I combine a true and a false statement together with the word AND, will it be true or will it be false? It will be false. My next row is a true statement in the first one and a true statement in the second one, so that would be true. And then the reality is these last two are guaranteed to be false. Why? They both start out false, right? The first statement's automatically false, so for an AND statement, that's enough to tell you they're both false after that. All right. I want to show you a YouTube video really quick because when you watch it, the other half of this lesson on online, the YouTube video won't come through, and then you're going to be like, what is she talking about this video? We didn't see a video. That way you'll know what I'm talking about. So I'm going to stop this video here.